Hey guys, welcome to Safi Mixed. In this video, I will tell you about the solution of an indeterminate result in the output of Mathematica like the one you see over here. And in particular, if you are doing your calculation for a problem related to quantum information theory or quantum computation, this result may arise because of the product of 0 with log to the base 2 0 like over here. This happens because log to the base 2 0 by default in Mathematica equals to minus infinity. We can check this over here, and minus infinity multiplied with 0 gives indeterminate result. To give a solution to this problem, let us make a little calculation. This is a pivot density matrix of a two-level system, and I want to find the eigenvalues of this density matrix by using the command eigenvalue like I'm doing over here. This is obvious. There are two eigenvalues. The first one is 1 and the second one is 0, but let's do it, and I can check that this is really the case. If I check this over here, I get two eigenvalues. The first one is 1 and the second one is 0. So I don't need this thing, and I want to construct a relation for one Newman entropy in the form of this one relation. I call this entropy. I apply the minus sign and then the sum, and this is the extraction command that would extract the eigenvalues one after the other from this list. EIG, we saw that within this list there are two eigenvalues. So I sum this result over the two eigenvalues at this position like 1 and 2, and inside the argument of the log function I put again the extraction command for EIG. So if I run this result, it will give me an indeterminate result. In order to understand why is this so, let us find each term inside this sum one by one. And if I do that, here I'm doing that, I first find the first term with the first eigenvalue which equals 1, and the result of this would be equal to 0. And if I replace the 1 inside the argument of this extraction command with 2, and similarly this extraction command with 2, now I'm finding the log to the base 2. I can use this command for the log, and I can even use, I would like to put this way, I can use this way. So if I run this, I'll get indeterminate result because the second value is 0, and we get 0 times minus infinity, which give me indeterminate result. I want to give a solution to this problem, and that I can do by first unprotecting the default command of Mathematica for log to the base 2, which is log to the base 2 0 equal to minus infinity, and then in the second line I tell Mathematica to set log to the base 2 0 to 0, and this is what we do in manual calculation. In manual calculation we set this thing equal to 0. So then I again ask Mathematica to protect the command of log to the base 2 for the rest of values. That is, only this value for the log to the base 2 is omitted from the default of Mathematica, and the rest of the calculation it will do with the default, and the rest of the calculation with log to the base 2 will be done what is in the default of Mathematica. So I read this to Mathematica, and then I want to re-evaluate the entropy relation. I can do a little practice over here. I can multiply anything like x with log to the base 2 0, and this will give me 0. You see, now if I run the this command either at this position or I rewrite this over here and run it, then I'll get 0 result, which is different from this indeterminate result and is actually the equivalent result for the entropy of this density matrix. So you can while the indeterminate result, if it is arising because of the 0 times log to the base 2 0 in your relation for doing your calculation, you can do it this way. If you haven't subscribed to SophiMax, kindly support the channel by pressing the like button on the video and the subscribe button on the channel. Thanks for watching.